Welcome you all for the second webinar organized by IEEE Power and Energy Society Sri Lanka chapter. Today the webinar is on status of implementation of energy efficiency initiatives, which will be conducted by our distinguished speaker, Dr. Tilak Siyambalapitiya. Dr. Tilak Siyambalapitiya has worked on promoting and teaching energy efficiency since 1983. He is an accredited energy auditor in Sri Lanka and has taught energy efficiency at numerous university courses and at energy management training programs. He will be speaking on Sri Lanka's achievements in implementing energy efficiency initiatives and what more remains to be implemented. He will be also focusing on supply side and demand side initiatives, devices, appliances, and systems that need attention to make them more efficient. I cordially invite Dr. Simla for the session, and I will remind you on the Q&A session. We have shared a link with you in email to add your questions for Q&A session, and the link will be posted in the chat as well. So you can post your questions for the Q&A session from that. Over to you, sir.
All right, good evening to all of you. So today we will be discussing the status of energy efficiency initiatives in Sri Lanka. My presentation is specifically about Sri Lanka, but occasionally I will be comparing the status of Sri Lanka with respect to other countries. So let's move on. What are the four areas I plan to cover, or rather the questions that I try to answer? At national level, how do we measure energy efficiency? And is Sri Lanka an energy efficient nation? Secondly, what are the specific achievements that Sri Lanka has had on energy efficiency? Then what are the gaps in various regulatory activities that we hear every now and then? And finally, the remaining initiatives that are yet to be implemented at the customer end. So I will take you through this over the next 40 minutes or so, and then we will get on to the Q&A. Slide shows a lot of things. The green line shows that the energy requirements in Sri Lanka are increasing as expected. And you would see that I've limited the display to commercial energy. And read the commercial energy quantity on the right-hand side. Sorry, on the left-hand side. Commercial energy use per person, considering the fact that the population is also growing. The green line has increased from about 75 kilograms of oil equivalent per person in 1980 to about 250 kilograms of oil equivalent per person by year 2017. By the way, at the bottom, I have explained what I mean by a ton of oil equivalent, or a kilogram, or correspondingly a kilogram of oil equivalent. 1 ton of oil equivalent is equal to 10 gigacalorie. What the red line shows is the commercial energy intensity. How is commercial energy contributing to economic development? Are we using more energy for the same economic development, or are we using less energy? So the red line, it has to be read on the right-hand side axis, has been about 14 tons of oil equivalent per million rupees of economic output. And by 2010, it has come down to about 10 tons of oil equivalent per million rupees of economic output. So basically, the energy intensity in Sri Lanka with regard to commercial energy use is fairly stable. Of course, commercial energy excludes all forms of non-traded energy. That means it does not include biomass, which is not traded but collected and used. Of course, there is a certain quantity of biomass that is available in the commercial market as well. How does Sri Lanka compare with other countries? In other words, what is the answer to the question as to whether we are an energy efficient nation or not? So this graph shows on the horizontal axis energy use per person per year in kilograms of oil equivalent. And as you see, Sri Lanka is around 500 kilograms of oil equivalent per person per year. And on the vertical axis, energy intensity in the economy. It is the inverse of what you saw in the previous graph. It is economic output per unit of fine. We are at slide 4. Sorry about the interruption. So what this shows is on the horizontal axis per capita energy use, and on the vertical axis economic output per unit of energy use. And it shows only a limited number of countries that have a per capita GDP, gross domestic product, in the range of $3,000 to $4,500 per year. For example, Sri Lanka last year reached $4,100 per person per year. So that gives you a feeling of the range of countries we are talking about. So if we compare ourselves with countries of similar economic development, Sri Lanka's position is fairly high among them. On the horizontal axis, we are at the lower end. That means we use a lower quantity of energy. And on the vertical axis, for that amount of energy, we produce more economic output. So the story of Sri Lanka as a country in terms of energy efficiency and in terms of energy economic output per unit of energy is relatively good. So with that positive note, let me move on to the next slide. Let me move on to the next slide, which shows a number of countries, in fact, almost all the countries that report data to the World Bank database. The horizontal axis has no relevance. It simply is a country. On the vertical axis is the total energy use per kilogram of oil equivalent per person per year. And as I said earlier, Sri Lanka is around 500. And the country that has the highest energy consumption per person per year is Iceland at 18,000. So you can imagine the country that uses the largest amount of energy per person uses 36 times the amount of energy used by a Sri Lankan. And the worldwide average is 1,900 approximately. That's about 4 times what a Sri Lankan uses. So armed with this data, let's move on what's happening. Of course, the national statistics indicate economic use of energy. International comparisons are good. And so what made this happen? What did we do to get such good marks? Let's look at the different users of energy, because energy efficiency is largely an end-use activity. There is very little you could do on the supply side, but we will come to that later. So out of the 3 major sectors that energy is used in the country, of course, industry shown in red, and the transport sector is shown in yellow, and the households and commercial and other miscellaneous activities shown in blue. All of them are growing. 20 years ago, we used only about 7,000 tons of oil, rather 7 million tons of oil equivalent. And now it has grown to about 10 million tons of oil equivalent. But as you see, the manufacturing industry, although the share is small, is managed reasonably well. And similarly, as we know very well, the households as well as the commercial sector are significantly energy conscious. The difficult portion is the transport sector. As we know very well, the transport sector uh, fuel usage is significantly increasing and not in a very inefficient manner. We'll come to that later. Largely, it is good housekeeping by both the energy suppliers and, more importantly, the energy customers has been the most important initiative that has brought in this level of energy efficiency and conscious use of energy. Sri Lankans still, at least 50% of households use biomass for day-to-day cooking. And there have been initiatives starting from about 1980 to introduce energy efficient ways of using firewood. The picture on the left-hand side, you still see, but the frequency of collection of firewood has become less. The picture on the right-hand side is a pottery worker making clay stove that you could buy and keep it in your fireplace and use. And then that stove will use energy efficiently compared with the traditional 3 brick fireplace. Thank you. I will move on. I will move on. Again on the supply side, the electricity transmission and distribution network is a topic that is very frequently discussed. And in 2002, the losses were of the order of about 20%, which have now declined to 8.8%. And the target is to bring these losses down to 7.5% by 2020. So Sri Lanka is doing reasonably well compared with the struggle experienced by other countries in reducing the losses in the transmission and distribution network. And as you see here, targets have been set for the transmission entity and to each distribution entity to be met year by year as we race towards the 7.5% target by 2020. So although it's not the best, the supply side efficiency of the transmission and distribution network is much better compared with what it was. And perhaps by 2025, we may have a 6.5% target. So as you see here, different distributors, there are 5 of them in the country, and the transmission network have been given individual targets to be met. For example, in 2018, you see the loss targets that were given to each distribution entity and how they fared on the right-hand side. So the performance has been reasonably good, and the national target was 8.9 and the achievement was 8.8. So as we go on reducing the losses, meeting the targets will be increasingly difficult. That's to be accepted. There are some other achievements. These curves tells us a lot. This is the demand profile of the country. On the day that the maximum demand occurred in a number of years, the most recent being 2017. And for convenience in comparison, I have normalized the curves to their maximum value. So that is why the vertical axis is 1 per unit. And the horizontal axis is the time of the day. So with respect to the maximum, which usually occurs in later in the evening, as you see, the curve is rising in all the other hours, and the rise is stronger during daytime. Say, for example, the blue line was only 60% of the maximum in the middle of the day in year 2005. Now the red line, which is 2017, is 80% of the maximum. Of course, in the off-peak hours, very early in the morning, 2:30 a.m., the blue line was at 40% of its maximum 15 years ago. But in 2017, it just touched about 50% of the maximum. So we see that the utilization of the assets, which is reflected by a increasing or rather increasingly smoothening load profile, is also an indication that energy, in this case electrical energy, is being managed better than what it was 15 to 20 years ago. So when the demand profile smoothens, that also indicates that the transmission and distribution losses would be less, and the assets that have been built are being used better because they are loaded for a longer period of time rather than not being used most of the time when you have the demand significantly lower during off-peak hours compared with the peak hour. Moving on, I'm quoting the Sri Lanka Sustainable Energy Authority, the submissions they provided to them by various customers. Say, for example, in 2013, 28 companies made submissions to Sustainable Energy Authority claiming the National Energy Awards. And these are the quantities of energy that they claimed that they have saved per year. So these numbers keep on adding up, showing the desire and the achievements of our energy customers in saving energy. Now, what are the customers doing? Of course, if we consider some major customer groupings and consumption categories, efficient lighting and the use of more daylight. As we know, energy efficient lights in the form of CFLs and LEDs are penetrating now almost 80% of households. Introduction of skylights in commercial and industrial buildings where light comes through the roof, and improved design of buildings to use more daylight is now very common. And in the households, the use of more efficient refrigerators, there is more work to be done there, is increasingly common. In the industries and buildings, almost all lighting has now switched on to more efficient, so-called T5 linear fluorescence and electronic control gear. And more efficient air conditioning systems, chillers have come into place. And there is greater care in insulating as required hot surfaces as well as cold surfaces. And the introduction of motors of the higher efficiency classes is now increasingly common, where you could pay more and buy a motor which is 2% or 3% more efficient than the motor of the standard design. The use of variable speed drives. As we know very well, industrial drives require a different speed at different times depending on the production process. So the age-old practice was to throttle the airflow or the water flow, but the correct practice to save energy is to change the speed of the motor. So variable speed drives are widely used. so that energy is efficiently used and not wasted in the throttling process. On the thermal side, more efficient boilers have come into place, and improved management of the soft steam distribution systems is something that we see is being done much better than what it was 2-3 decades ago. So these are some good achievements. On the regulatory side, on the regulatory side, standards and norms. On standards and norms, what have we done? ISO 50001, which is the certification on energy management systems, is now in place. It's of course not mandatory. It's a voluntary participation activity. Then, of course, changing from conventional approach to green building concepts is going on. Many institutions, many individuals, many companies are involved in this process. Sri Lanka also published a code of practice for energy efficient buildings, which you see in the picture here. It's cover page. It is yet to be declared as a mandatory requirement. For the last 15 years or so, it has been there as a recommended code of practice. We have achieved establishing energy performance of widely used appliances, starting with the compact fluorescent lamps, initially as an optional standard, but from 2009 as a mandatory standard. And energy labeling for ceiling fans had been made compulsory very recently. And progress with labeling of other appliances, although one would wish that they also have been compulsorily labeled by now. It's not yet, but very soon, refrigerators, air conditioners, televisions, water pumps, all these appliances are scheduled to be brought in to what is called the labeling regime. As you see, the label gives information to a customer about the star rating of the appliance. That means the energy efficiency rating of the appliance, which also indicates that unless it is carrying at least 1 star, it is prohibited to sell that appliance, and giving additional information about the capacity of the appliance as well as the energy consumption per month of the appliance. For LEDs, which have recently come into the market, a non-mandatory energy performance standard and a label is already in operation. Hopefully that will be made mandatory within a couple of years from now. Further activities, energy manager and energy auditor regulations have been operational for a few years now, where all large companies are required by law to have an energy manager on their staff. Energy auditors are also being accredited now. That's a specialized profession. Then, of course, a large number of capacity building and training activities have been completed. Energy auditor training course, energy auditor or energy manager training programs, and also the Sri Lanka Energy Audit Manual, of which you see the pictures below, has been updated and published in year 2013. All these go to support people with good information, guidelines, examples of how energy could be managed better and how energy could be used more efficiently. Of course, our major area of growing concern remains the transport sector. As you see in the diagram, as published by the World Bank, on the horizontal axis is the GDP per capita. And as we know, Sri Lanka is still at a much lower level on this graph at 4,000 on the horizontal axis. On the vertical axis are actual road sector energy consumption figures per person. And as you know, again, Sri Lanka's total energy consumption per person is 0.5 tons of oil equivalent per year. So therefore, Sri Lanka is in the cluster of countries that are over here presently using about 30% of our all energy consumption on transport. But as you see, there are many countries who are bad examples that we should never be emulating. And there are countries that perhaps are better examples as we go on into the future in growing as a country, but keeping our per capita energy consumption for transport as low as possible. Hong Kong is perhaps the lowest that you see over here in terms of per capita energy consumption. Then Singapore, most of these are city states, but consider UK, consider Japan, who place large emphasis on energy efficiency in transport. And these have been achieved through a mix of initiatives, which are some of which are technical, some of which are planning, with good investments and good maintenance of particularly the public transport facilities. So national per capita energy use in transport is still not high, but it has a potential of moving in a dangerous direction. Public transport share has dropped below 50%, and it has caused inefficient use of energy, excessive emissions, as we all know, and higher costs of transport. And therefore, transport requires much better planning and investments and institutional reforms to completely reorganize and restructure public transport and increase the share of public transport, which is threatening to drop below 50% now, and compel and encourage people to use public transport. There is another area that requires special attention. Perhaps it's nothing new. Our street lighting system. Our street lighting system, I'm sure anybody would agree, is inadequate and it is technically inefficient. Street lights are perhaps not always in the correct place, not at the correct height, not at the correct spacing, and most likely not using the most efficient lighting device that should be used for that particular application. Nevertheless, Sri Lanka used 166 gigawatt hour, that is about 1.2% of total electricity used in the country, for street lighting. And as we all know, nobody pays for street lighting. That means everybody pay for street lighting altogether, because unseen to any of us, it is a component in our electricity bills. And the majority of street lights are unmetered individually or even group wise. So therefore, there is no check on how much of energy is being used for street lights, and together with it, the requirement to go in for better controls, as I have shown on the right hand side. The need for remote switching is very little, the applications. Then switching options, for example, all the street lamps do not have to be on after midnight. Maybe every other street light can be switched on. And the quality of lighting and the quality of lighting devices and the adequacy of lighting. So therefore, although street lighting perhaps is considered a trivial matter, street lighting requires a lot more attention. Number one, to improve the quality of street lighting, and number two, to improve the efficiency of energy used for street lighting. More actions are required on demand side management. DSM means demand side management. So, what is demand side management? Demand side management is slightly different to energy efficiency. If you switch off a light in your house, then you are doing a deed with regard to good housekeeping. If you replace an incandescent bulb with a LED bulb, then your action is to improve efficient use of electricity for lighting. But if your electricity supplier says, I will provide efficient lighting to you, lighting devices to you at 50% of the cost, Now that is demand side management. That means you and the electricity supplier, and by extension the government, are jointly participating to save energy, to reduce demand. Then, what has been done so far? What has been done so far? Presently, there is a time of use pricing activity which is compulsory for low voltage bulk customers and for medium voltage customers as well. Then, of course, the time of use pricing, which is price of electricity that varies during the day, is still not compulsory for households, but it is compulsory for bulk customers. There is an optional time of use pricing for households, but not many people have taken it up. There is another aspect that requires attention, that is what incentive have the electricity distributors got to improve or manage the demand. Presently, our electricity distributors, be it LECO or CEB, in fact have no rewards if they take action to manage the demand. So therefore, there has to be a complete rethink, because in most countries that have even achieved much smoother load profiles than we have achieved so far, electricity distributors are a significant stakeholder in assisting the electricity users to manage their demand. And in certain countries, there are third-party companies coming in. A third-party company is not the electricity distributor, is not the electricity user, is not the government, but a completely different independent party who is promoting energy management. And of course, as electricity can be measured very efficiently and online, the performance of the demand management agency, or in some countries they are called aggregators, can be easily measured. There are certain weak areas at industry level. Of course, when we walk into an industry, the traditional uh, ways in which energy was wasted are no longer to be seen. The insulation is good, the boilers are good, uh, their efficiency is being monitored, but there are a few systems that we see, particularly in manufacturing industries, which need attention. Compressed air systems is one area where many people forget that compressed air is energy. There had been an energy input to produce compressed air. So it has to be carefully used and not wasted. Then the management of air conditioning systems. Common examples are many. Disconnection of temperature controls and disabled variable speed drives. So these drives have been installed to maintain the speed of the pumps and the motors, but after a while they are disconnected, so therefore the efficiency gains are lost. Most importantly, information collection and metering. Actually, less than 10% of industries, according to our estimates, have separate metering in separate departments. That means if it's an office building, at least flow by flow metering, and also a system to collect this information on energy use and conduct regular analysis are absent in most of the buildings and industries. So these have to be set up so that there is good monitoring of energy use. Then, of course, weak areas at industry level, advanced technology. Earlier, we were talking about known technology. But on the left-hand side, I have again said advanced but established technology. There are established technologies, but on which we have not seen much implementation in Sri Lanka. For example, cogeneration, generation of electricity and heat in a power plant. Trigeneration, heat, electricity, and air conditioning. Three forms of energy conversion, all in one, which can bring in a much higher efficiency of energy use. Thirdly, thermal energy storage. I will come to that in a moment, what thermal energy storage is, which is very viable for Sri Lanka to use. But we see only a handful of thermal energy storage facilities in operation. District cooling. Now, what is district cooling? If there are several buildings that require air conditioning in a cluster, then these buildings can have a common air conditioning facility. So the common air conditioning facility can deliver chilled water to each of the buildings. And of course, as you know very well, when the facility is common, the services are much better and cheaper, and the investment is lower. I hope that in the upcoming port city project, there will be at least one or even several district cooling facilities, because it's going to be a planned city. And planning a district cooling facility will be a job that has to be considered right from the beginning of the urban planning activity. Of course, there are new technologies that are still only at the pilot stage. Demand management using information technology tools, then smart buildings, then comprehensive building energy management systems, and of course the maximum use of renewable energy. These are at very early stage of implementation in our country. Of course, renewable energy is being used, but the maximization and how it can be integrated into energy consumption in a building or an industry rather than selling it all to the grid are things that we need to consider as a part of an energy management activity. I said thermal energy storage. Now, what is thermal energy storage? Thermal energy storage is basically in the context of Sri Lanka, where the demand is for cooling. This is space cooling. It could be industrial cooling as well. But basically, the brown curve is the requirement of electricity for a particular industrial process. It's not related to cooling, the industrial activity. Whereas the blue curve represents the cooling power requirement, electricity requirement for cooling. And most of the time, these requirements coincide on the time scale. But what if we can shift the cooling requirement or the electricity used for cooling to the off-peak hours, when the industry does not need electricity? Outside the brown color curve, we run a cooling facility and store chilled water or store ice, and then use that to produce space cooling during the time when the industry needs electricity for other things. So this is the simple concept of thermal energy storage. There is not much of a sophistication, but it requires careful planning, careful costing, as well as careful control, so that the thermal energy storage system will be optimally designed and optimally operated. So this is part of known technology, very well practiced in many countries, including almost all countries in the Middle East, where certain buildings are compelled to have a thermal energy storage system right at the beginning, not as a retrofit as we are thinking. I said analysis is weak in our energy consumption facilities. So these are two famous curves that I show. The curves show for a building or for a hospitality facility, what is the percent occupancy over so many months, and what is the specific energy consumption in terms of energy per unit of output or energy per room. So as expected, when the occupancy or the usage is more, the curve comes down. And for a larger facility, such as the one shown in purple, the specific energy consumption will be lower, and a smaller facility, the consumption curve will be higher. So we lack this kind of analysis and information shared among all industries for their particular industry, and a good understanding of the energy consumption levels and correlating them with benchmarks. So this practice of not only measuring, not only keeping records, but analyzing them using simple scientific and mathematical approaches should come in to use in a larger scale. Otherwise, meters are fixed, energy is measured, records are kept, but nobody analyzes them. So this is my last slide, or the one before last. How much do you think we can save more? Of course, remember, it'll be saving through efficiency improvement and demand management. And there would be appropriate investments which are financially viable. Energy efficiency improvement requires investment. The era that you could switch off and save energy is gone because we are already switching off. So when we use biomass at home and industries, how much can we save? Petroleum refining on the supply side, petroleum distribution, how much can we save? Electricity generation using available power plants, our existing fleet, transmission and distribution, electricity use at home, electricity use in commercial buildings, industries, thermal energy use in transport. So in the next one, which is my last slide, I have put some numbers, which I think, of course, all these require good analysis, further analysis as to how much we can save. Because I need to dispel the myth that we can save 50%. There is no case or possibility of saving 50%. But as you see these numbers, biomass use at home and industries, easily a 5% saving potential. Petroleum refining, petroleum distribution, we are still within 1 to 2%. So maybe 0.5% saving. Electricity generation efficiency improvement in hydropower plants, thermal power plants, perhaps 4% efficiency improvement. Transmission and distribution, we are already at 8.8, perhaps a 2% reduction to 6.8 may be possible. Electricity use at home, perhaps 5%, commercial buildings 5, industries 5, thermal energy use in industries 5, and I have no answer for the last bullet point. How much can we save in the energy we use for transport? Because the gap is so wide, as you know very well, the energy used per person in a train perhaps could be even only 5% of energy used by a person who is taking a car ride for the same trip. So therefore, how much can we save depends on the transportation network in the future and how much we invest into the future and how much people change their attitudes and practices in using transport and making use of the public transport that is available. So that's my last slide, and I hope it has been of interest to you. And I believe the organizers will now pose questions uh, that we have received from you.
Thank you very much, sir. Uh, for the Q&A session, we have received questions. So the first one is, what is the role of the regulator in increasing efficiency of electricity usage?
Fine. The role of, or rather the responsibilities of regulating energy efficiency in the electricity industry has been divided between two regulators. On the supply side, efficiency improvement is the responsibility of the Public Utilities Commission. So that's why PUC has given the transmission and distribution loss targets, and also the efficiency of power generation is monitored, and as well as the way in which power plants are operated so that optimum efficiency is achieved. Their combination is monitored by the Public Utilities Commission. But electricity efficiency improvement on the end use side is definitely the responsibility of Sri Lanka Sustainable Energy Authority. And Sustainable Energy Authority is the agency that is also responsible for renewable energy development and regulation and energy efficiency, both in electricity and in fact all forms of energy is a responsibility of the Sustainable Energy Authority. So their role is capacity building, training, licensing, accreditation, promotion, arranging finances and assisting customers, publicity, uh, anything that you can name that work towards energy efficiency and demand management is the responsibility of the regulator to make sure that it is done.
Thank you, sir. The next question. LED bulbs are given free in India and South Carolina on the base rate approved by regulator. Is that a good approach for Sri Lanka to flatten the curve?
Well, I would say yes. Now, perhaps India is starting off at a different point compared with Sri Lanka. The reason being that Sri Lanka has already gone through a very major compact fluorescent light program in which the government and the electricity suppliers implemented the demand side management project in the early part of the year 2000 and coming up to about 2004. Certainly, in my view, assisting the customers to move to efficient lighting is really, that has to be an ongoing activity. So as we see, Sri Lankan customers are sensitive to electricity costs. So therefore, they are voluntarily purchasing efficient lights. So there is one responsibility of the government and regulatory agencies and standards institutions to make sure that the standards are there and the standards are implemented and enforced so that the customer purchases a quality lighting device. So there is a gap to be filled there in Sri Lanka. Whether LED bulbs should be given free of charge, it should be a result of an analysis. So Sri Lanka started off giving compact fluorescent lights free of charge in the 1990s and then moved on to giving them on the basis of an interest-free loan in the latter part of 1990s. Perhaps another program, particularly when standards are enforced for LEDs in our market, I would say would be a good thing to do to ensure that customers have good quality LEDs and the correct amount of lighting to be used by customers, because right now there are quality is not the only problem, but the quality of light, the color of light, all these things matter, and these will be covered in the standards.
Yes, sir. The next question. What is your view in electrification of transport sector? The utilization of modes such as light rail systems, electric trains, and electric buses can be considered as energy efficient initiatives in Sri Lanka.
Yes, for sure. There is no doubt electric transport, whether it is an electric car or an electric bus or an electric train, whether it's a light rail or a heavy rail, energy efficiency is definitely much better than individual transport or small group transport or even bus transport. But it does not mean, given the fact that some of the electrification, particularly railway and light rail, are highly capital intensive. In my view, we should, of course, electrify all the existing railway, particularly the heavily used sectors of the railway network. For example, the Colombo suburban railway network. But we should also spend more and have a very clear policy on introduction of larger scale electric transport, I mean the road transport. I'm not particularly in favor of significantly promoting individual cars, individual electric cars, because finally they are going to create that unwanted traffic jam. So we may have a lesser impact on the environment because it's electric, but then the traffic jam will still be there. So what we should be promoting are the lower capital intensive electric buses, which bring in the benefit of being a public transport element and also the benefit of being electric, so that the emissions will be lower and the overall efficiency will be more. Simply put it, we produce electricity in power plants. It is true that 50% of our electricity comes from renewables and the balance 50% comes from fossil fuels. So, but fossil fuels can be burnt in power plants more efficiently than it is burnt in an internal combustion engine in a bus. So therefore, even if electricity is produced with fossil fuels, it is still cheaper, more efficient, and environmentally better in using electricity to run public transport.
Okay, sir. The next question. Nowadays, some places use street lights with batteries. Considering the lifetime of the solar panels, batteries, and negatives, do you think it is a reasonable approach to Sri Lanka?
Well, in my view, it's a maintenance problem. We should not fix anything of which we are not capable or not geared to conduct regular maintenance. So, if you are referring to the solar street lights with batteries that you see along walking tracks or in some streets as well, I have no problem with it. But the problem is it's one party who installs it and the party who maintains do not know how to maintain it, or they do not maintain it at all. So once the battery life is gone, still the life of the solar panel and the light fitting is still there, but the battery is not replaced, so it goes into disuse. So my thinking is that until we get ourselves organized, it's much better to provide street lighting using the mains. But the day we are able to maintain that battery, then let us go for more solar lights with the batteries. But until then, do not fix solar lights with a battery which you do not maintain, and you see hundreds or perhaps thousands of them all over the country, particularly along walking tracks and beach parks, which are not maintained, not working.
The next one. Reflective tariff and demand-side management on the two opposite ends. Is the tariff structure itself tool for increasing efficiency, as in Sri Lanka?
Of course, the theory of pricing says that you should price a product at what it costs. So therefore, if you price electricity at what it costs, what happens is that the price of electricity to households will be the highest. Why? When you calculate the cost of supply, households are a peak time customer and they use a lower quantity of electricity in relation to their connection capacity and the peak demand, and they are at the tail end of the distribution network. So therefore, the upstream network investment is the highest to reach a household customer. So unfortunately, household customers are the most expensive to supply, and you will see that many countries price electricity to households at levels much higher than the electricity supplied to larger customers. But in Sri Lanka, it is not so. For about 80% of household customers, electricity is significantly subsidized. So, in my view, it is much better to actually price electricity at what it costs, but to deserving households to provide a subsidy which is targeted and declared so that the customers know the value of a kilowatt hour of electricity which appears in their bill, and the subsidy that they are given is also printed on the bill itself. But the present way of pricing does not encourage demand management, particularly at the household level for households who are using a lower quantity of electricity. Tariff structure in general should give the correct signal to improve energy efficiency. So we have gone halfway there, even the time of use pricing, which was optional for all customers until 2010. For the last 10 years, it has been mandatory for large customers. It has been mandatory, so we see hotels, large commercial buildings, industries are responding to the time of use pricing. So that's why in the family of curves I showed you, in fact, what is also happening is that the peak is not growing, but the off-peak is growing. So why isn't the peak growing? Partly because of efficient lighting, and partly because we have completed electrification of households. So no new households are being added in large numbers as it was before when the grid was being expanded very rapidly. Then thirdly, and most importantly, the large customers are responding to the time of use pricing and cutting off their demand in the peak periods. So definitely electricity pricing, particularly the time of use pricing, is already showing its benefits uh, in managing the demand.
We have two more questions. If we think of implementing thermal energy storage in Sri Lanka, what about the infrastructure requirements?
Yes, thermal energy storage is, as things are, if it is a retrofit, it is specific. It is specific to particular premises. So the infrastructure has to be built within the premises. So the main barrier is the lack of space in most of the premises which have a potential for thermal energy storage. So I see that as a barrier. So unless it is built into the original design, companies may not have space to have a tank that stores either ice or chilled water during the off-peak hours. So subject to that limitation, the infrastructure has to be built by the company itself. It's basically a storage facility, and the rest of the infrastructure is already there. The chillers are there, the piping system is there, pumps are there, and it only requires storage and the control system. So I don't see it as a major problem, but it has an investment. And of course, as I always say, that investment should be worth it. And the benefits are that you have a lower electricity bill. So it's a financial saving because you shift your demand. Then secondly, your chilled water manufacturing facility is running at maximum efficiency in the off-peak period. So you have an energy saving there. Of course, some energy is lost because when you store chilled water, there is some heat gain.
Next one. What is the viability of battery storage instead of cooling storage systems?
Well, this has to be studied quite a lot, but given the cost of the batteries, so what you visualize is instead of storing energy in the form of chilled water to be used for air conditioning during the day, why not store electricity in a battery during the night and run that battery or use that stored energy in the battery to run your chiller, to run your air conditioning system in the peak period. So battery storage costs have still not come down adequately in my view, but this is not an analysis that I have done. Perhaps with this question, perhaps it's an analysis we should be doing as to whether battery storage will be more economical than thermal energy storage. Of course, there is an advantage when you have a battery storage because battery storage gives out electricity which you can use for anything. not only to manufacture chilled water. So therefore, once a battery storage is there, you can use it for running a machine in the factory. So that advantage is there. So the answer to your question is I cannot give you a definite answer. We need to analyze the economics.
The last question due to the time. Could you please inform how the post-COVID period will influence the energy efficiency initiatives?
So the question is how the post-COVID period will impact the energy efficiency, will influence the energy efficiency initiatives.
Yes.
Well, the uh, the good thing is that the inefficient power plants do not need to be run because right now the peak is suppressed. So therefore, Sri Lanka is largely managing with the low cost power plants and renewable energy. So that benefit is there at the moment. What I see some negative aspects because energy costs, at least the economic costs of energy, are going to be low for quite some time into the future. So oil prices will come down, coal prices also definitely will come down. So therefore, uh, although energy is so valuable, including fossil fuels, their apparent cost to the economy will go down. So in a way, I feel the government's decision not to decrease the petroleum prices is a good one, so that energy efficiency at least will have the same level of priority as we had before. Because at the end of the day, it's not the value to the economy that is felt by the customer, it is the value to the customer. So a company will not implement energy efficiency measures unless there is a financial benefit, unless the payback periods are within company norms. And those payback periods will be much longer if you bring down the energy prices as a result of what's happening in the international market. So therefore, keeping energy prices at the present levels is most important. And of course, providing subsidies to whatever industries directly and clearly identified to resolve their other problems. So that's the major influence that I see that the present health situation has brought in. It's an indirect influence. But otherwise, as industries pick up and buildings start operation again, we should continue with our energy efficiency activities into the future.
Thank you very much, sir. It was a very informative session. And we are very thankful. So I invite Randima to wind up the session with a thank you note.
Hello everyone. We are at the end of this webinar of IEEE PES Day on status of implementation of energy efficiency initiatives organized by IEEE PES Sri Lanka chapter. So we would like to extend our gratitude to Dr. Tilak Siyambalapitiya, an accredited energy auditor who is the Managing Director of Resource Management Associates Private Limited, for conducting this session for us by dedicating your valuable time. Thank you for sharing your experience and insights on this aspect with us. We hope the information that you shared with us will be helpful as professionals and students in the power sector. So thank you again for your thought-provoking and well-presented session, sir. Dear
Thank you
participants,
very
we
much.
were thrilled by the attendance and thank you all who participated and helped to make this webinar a success. Hope you all will keep in touch with us for future webinars with us. So at last but not least, we all are facing a global pandemic, COVID-19 these days. So hope you all are safe, keep distance and wash your hands properly. Have a good day.